Okay, so today's research overview, we're going to be focusing on number sense. What is number sense? So there's lots of ideas about that, but the research, it comes down to really 5 components. And what we want kids to do is have this really amazing conceptual framework for numbers. And this starts in those early years, as early as age 4 and 5. Okay, so these 5 components. The first one is number recognition. Okay, so if a young child sees the numeral 3, so being able to understand that 3 represents 3 friends, 3 apples, 3 steps. That's the first initial idea of starting to build number sense. What does that number and numeral mean? Second is we want to look at number relationships. So that comes down to composing and decomposing number. So if you take 5 cubes and be able to decompose that and understanding that 5 is composed of both a 3 and a 2, or 4 and 1. Or composing larger numbers, 5, and you compose 2 more to get to a new number 7. So being able to look at those relationships is really critical. Then the next one is magnitude, number magnitude. So being able to understand the size of numbers. And that really comes down to truly the number line and the bar model. The bar model is a rectangle that recognizes the different lengths and sizes of numbers. So we want to be able to see, like our last example, that here's 5, and then if 6, it's going to be more. And we want that to be in proportional relationships. That's one of the critical things, because I see a lot of activities where kids aren't doing things proportionally. So we actually want to be able to see a number and what numbers are less and more in that relationship. And that's why the bar model and number line are so effective. Fourth area is just number operations. So being able to understand that the plus sign when you're adding is going to increase the amount. So if you have the number 3 and you add 2 to it, that's going to increase the size. So that operation. Another operation, subtract. So when they see subtraction, you might subtract. You have 3 and you subtract 2, and then you get 1, and that number is less. So that's the 4th component. And the 5th component of number sense is being able to look at relative benchmarks. So it could be things like 10, knowing that 10 is a benchmark, counting by 10s, knowing that 1 less than 10, 1 more than 10, where are we? So those are the 5 components. So being understanding those operations and what they do to numbers and those relative benchmarks. So the next component is, what are we going to do about it? Okay, so what are some things we can put in place to really help with that process? We're going to do another video for teacher tips that go through different examples. You can watch it in different examples. But there's really 6 things that you can work on. So the first thing that you want to work on is subitizing. So that's Latin for suddenly seeing. It's like if you have dominoes or dice, being able to look for patterns and seeing the number. So being able to look at maybe if you have a dice and you see, oh, that's 6, that's 4. That's a really important idea. And you can do that by just, as a parent and teacher, just walking around the environment and looking for things where you see 2, 3, 4, 5, and maybe up to 6 and 7, and then after that, usually you're composing 2 different numbers. The second thing you can do is just counting. So a lot of times we just do the rote counting, but it's really important to actually have some objects. We count things 1, 2, 3, 4, 5, and even more importantly is to count backwards. 5, 4, 3, 2, 1, and 0. So that's the second thing that we can work on. Another idea is, again, when we're counting different objects, especially if they're randomly put in spaces, is to line them up in a linear format. And that's where cubes come in really nicely. You can stack the cubes, because that starts getting that idea of magnitude, and then we can actually break things apart, decompose them into different parts, and then compose them back together. So another thing that's really important to do is have kids see number with different visual representations. So like we said, with 6, the dice, usually those are in a pattern of a 2x3 or 3x2, depending on how you're looking at it. But also, can you see 6 things in a circle, 6 things in a line, so, 4 and 2. So we want to be able to look for different visual representations. The next thing, 5th thing, is on a number line, being able to put 3 numbers, 5, 8, and 23, where's the location on the number line, and what's the relative distance? That's a really important idea that you can actually implement in your classroom. The 6th one is proportion. A lot of times we think, wait a minute, we don't introduce proportion until 6th grade, but this is really important to get kids to even start seeing as young as 5 and 6 years old, that maybe 3 on a number line, we have 3, 6, 9, 12, and that relative size is increasing by 3 each time. Or maybe another good example would be, food is always a good one. You would take 2 oranges and 3 grapefruits. You squeeze those, you mix them together, and you have that drink. Now, if we want to make more, could we have 4 oranges and 6? So making sure that that proportional size, 2 and 2, 3 and 3, stays the same amount, and then we can test to see, does the drink still taste the same? What if we did just 2 extra grapefruit and 2 extra oranges, or 1 extra orange? Does it taste the same? That doesn't keep that same relationship. So there's a couple different things you can do to build on those 5 components to build the number sense. So if you have any comments, please leave them below, and then go ahead and like and share this as much as possible. Thank you.